Welcome to the Bentley Systems training course, where you will learn how to design combined footings using the Combined Footing Detailing module available within RAM Elements. Now, this detailing module can either be used as a standalone application or in conjunction with an analyzed model in the RAM Elements main application. For this training, we will be using it in conjunction with an analyzed RAM Elements model. Now, prior to invoking the Combined Footing Detailing module, it is recommended to first model and analyze the appropriate soil structure interactions for the foundation nodes. As you can see for this training, I will be using a model that has already been created in RAM Elements, and my foundation nodes has already been selected. Let's go ahead to the Data panel and select the Nodes tab, followed by the Springs icon. Within this area, you can enter your compression-only spring information along with your translational and rotational stiffness values. I'm going to start by selecting the TX and the TZ value, which will basically lock the structure in the horizontal direction for our compression-only springs. And then I will copy this information down to the currently selected nodes using the Copy Row at Cursor Location tool. Next, let's go ahead and enter the translational and rotational stiffness values, which we will enter by using the Model Soil Structure Interaction tool, available in the Spreadsheet tab of the ribbon toolbar. The first thing we're going to enter is our column location. RAM Elements permits the column location to be considered at one of 9 column locations indicated in the graphic within this dialog. We're going to select the center icon, which basically means that we have a concentric column. Next, we're going to enter our soil type information. Now, the modulus of subgrade reaction can be defined using a custom value or by selecting the soil type that most closely matches your product site location. For this model, I'm going to select a medium density sand. It's going to enter a value for me of 280 kips per cubic foot, which I am okay with. Again, I can create a customized value here if I need to. Next, I'm going to enter the approximate footing locations. I'm going to enter a base width of 4 feet and a length of 8 foot. And then I'm going to enter my rotational spring calculation information. Now, RAM Elements allows for 2 methods to calculate the appropriate spring constant, either the direct method or the Taylor method. I'm going to go ahead and select the direct method, and then we'll go ahead and click OK. As you can see, RAM Elements has automatically filled in my soil spring information given the parameters that I entered. Now at this point for this particular model, I'm ready to perform an analysis and design and then proceed over to the detailing module. To start that process, I'm going to go to the Process tab in the ribbon toolbar and click on the Analyze Model icon. After the analysis is completed successfully, I can perform the design and then proceed over to the detailing module. Once the design is completed successfully, I'm going to identify the nodes that I want to design as a continuous footing and then pass them over to the footing module. For this exercise, I'm going to select these 2 nodes at the braced frame at the back side of my structure. And again, I may want to zoom in and out to make sure I select the right entities. So I have my 2 nodes selected. I'm going to go to the Modules tab in my ribbon toolbar, and find my foundation tools. Now, if I were using this as a standalone application, I would use the standalone pull-down option. Again, these options do not require a completed RAM elements model, and they do not take any information from an analyzed RAM elements model. I'm going to be using this in conjunction with my main application model. So I'm going to go to my Assign pull-down menu and then select my combined icon. Now, when foundation nodes are imported from an analyzed RAM elements model, most of the information in the Properties window will reflect the criteria that was set in the main applications. There are a few pieces of information that we need to review manually. First, let's go to the Home tab in the ribbon and let's take a look at the Load Condition pull-down menu. You're going to notice that all of the load combinations, both service and design, have been imported into the combined footing detailing module as load cases. These load cases were each given a custom load combination with a factor of 1.0. Next, let's go refer to the Properties window, and we're going to modify the material data for our footing. So here in the footing area, we're going to specify our concrete material. For me, I'm going to select a C4-60, that would be 4,000 PSI concrete with 60 KSI reinforcing steel. I could enter the depth of the base of my foundation. I'm going to enter that at 5 feet. I'm going to enter a width of 6 feet and then a length of 30 feet. For the base height, I'll go ahead and enter that at 18 inches. Now, after you enter your longitudinal and transverse reinforcement for your columns, you're then going to proceed on to your soil data. And the first option we're going to see is an option to calculate your soil bearing capacity. Now, if the Calculate Soil Bearing Capacity option is selected, RAM Elements will calculate the soil bearing capacity based on some additional user information that you're going to enter. So here you can see if I selected this checkbox, and some of those parameters go away, and the program will calculate your allowable soil bearing capacity. If the Calculate Soil Bearing Capacity option is not selected, RAM Elements will design the foundation according to the specified soil allowable stresses. Here I'm going to leave this checkbox unselected, and I'm going to enter an allowable soil stress of 3,000 pounds per square foot. In addition to that, I'm going to review the rest of the soil data parameters and enter their appropriate values according to the site conditions that I have. Next, let's go ahead and take a look at the loading information. Now you're going to notice that the axial moment and shear force for each load combination has been brought over from the RAM Elements main application. And the loads should not be modified here, as again, they could affect the main analysis information. Next, let's take a look at the design moment field. Now you can include the overturning effect for the flexural bending moment caused by shear force transmitted at the column according to a few different options. Here we're going to go ahead and select the moment equals the shear times the thickness. Here we're going to select the last option, which is the moment. The overall design moment is the moment plus the shear times the thickness of the footing. Now the last piece of information we're going to take a look at is our design data for the calculations. Let's take a look at the length to width ratio parameter. Finally, before we kicked off our design and optimization of this combined footing, let's take a look at our design data, which are basically ways that you can use to customize your design or optimization process. Your first option for design criteria is your length to width ratio. With this option selected, the base dimensions are calculated complying with the length to width ratio previously defined by you. Next, you can also select a restrained width. or a restrained length, which basically means that these dimensions will be restrained to a fixed maximum value, and then the footing can grow in the other direction. We're going to go ahead and say that this is a restrained width, which means it's going to lock the width in place. The maximum width we're going to enter as 6.5 feet. And then we're going to say our dowels are in compression, and which bar sizes do we want to use for our foundation design. I'll go ahead and select I'm okay with number 5s, number 6s, or number 7s. Now, before we kick off our optimization, let's also review some of our advanced options. So in the Home tab of the ribbon toolbar, you can now click the advanced icon to review some of the concrete reinforcement, and the soil data and design information that you can enter for this particular continuous footing design. And this includes things like whether or not you have epoxy coated rebar, what type of concrete you're using, what type of forces do you want to include in the design, or the soil capacities. Once we're done, we'll go ahead and click OK, and we are ready to perform the design. Now, there's no analysis or design command in the combined footing detailing module. To perform an analysis and optimization, you're just simply going to click on the Optimize icon in the Detailing tab of the ribbon toolbar. Now, once the optimization is complete, your status bar at the bottom of the screen will be updated with the color coding scheme that we use. If your status bar indicates a green light, it means that your design has passed and no warnings or errors were found. If your indicator light is yellow, it means that your design passed, but a warning was issued. And if your indicator light is red, it means that your design failed, and perhaps you need to go back and make some changes and then re-perform your optimization. Now, what we're going to notice is that our traffic indicator light is yellow, which means that the design is complete, but we did receive some warnings. So let's go ahead and try to rectify that. So in the ribbon toolbar, I'm now going to select the Detailing tab, and what we're going to notice is that RAM Elements has designed the longitudinal and transverse reinforcement for this particular combined footing. And I can see that different types of reinforcement in the different areas within the data panel. What I'm going to do is I'm going to start customizing my reinforcement. So in the ribbon toolbar, in the Detailing tab, I'm now going to select the longitudinal reinforcement icon, and I can customize the reinforcement I want. So let's go ahead and say I want to use bars number 7. I'm going to enter them at the bottom location, and I'm going to hook them at both ends. So let's go ahead and click OK. In addition to that, I'm also going to delete. No. Now, before I go through any more optimization process, let me first customize my bars. I can see at the top and bottom for longitudinal bars, I received 8 number 5 bars. So if I want to customize that, I can customize this information directly in the data panel, or I can use one of the tools in the ribbon toolbar. I'm going to go ahead and click on the Generate Longitudinal Reinforcement icon, and I'm going to specify the bars I would like to use instead. So here I'm going to say 7 bars, number 7. They're going to be located at the bottom, and I want to hook them at both ends. Now, for any additional information, we do have this help window over at the right-hand side of this dialog to kind of give you a graphic of what you are detailing. So let's go ahead and click OK. Now, what we're going to notice is it doesn't remove the bars that were previously defined, so I can just go ahead and delete those. Let's do the same thing in the transverse area. Let's go ahead and delete all of the optimized bars. I'm going to click on the transverse icon, and then I'm going to say how many bars I want. So I'm going to say I want 12 bars. I want to use, say, number 5s. I am going to locate them at the bottom of the footing, but I'm not going to hook them. Okay, let's go ahead and click OK. So those bars were placed in zone number 1. Let's go ahead and click on this tool again. I'm going to enter this time 36 bars, number 5. No hooking, and we'll put this in zone number 2. And then of course I'm going to repeat this process for each of the zones within my transverse portion of my reinforcement. So once I'm done specifying the reinforcement, I can go ahead and check to see if my user-defined reinforcement was successful. So let's go to the Home tab of the ribbon toolbar and let's click on the check icon. After the optimization is performed, the first thing you're going to do is review your status bar at the bottom of the screen. This status bar will be updated based on the color coding assigned to your optimization. A green traffic light would indicate that your code check was complete and no errors or warnings were found. A yellow light, like we have, indicates that a code check was complete, but at least one warning was discovered during the optimization. And a red traffic light indicates that the design failed and you will need to go back and make some changes for a successful design to be completed. Now for our model, again, we have a yellow light which indicates there were some warnings. So the first place I'm going to go is to review my report to determine what changes I could make to my design to get away from those warnings. So let's go ahead and click on the report icon. And I'm going to scroll down. We can see that I have some warnings in design. And so as I scroll down, I'm going to look for those particular types of items. So here's my warning. It's basically indicating that the distance between the columns is larger than the required due to considered geometry footing. It's basically indicating that the distance between columns is larger than required to consider the footing as a rigid body. Let's go ahead and review the rest of it and see if there are any other warnings. Here I can see the status of my design. Everything is coming up green, which means that the code check did pass. Okay, so I'm not seeing any additional warnings. Let's go ahead and close this report. So from the report, I can see that my footing geometry might be not quite optimum of what it needs to be. When I did the optimize option, what it did was it optimized the footing size based on some footing parameters that I provided to it, along with developing the reinforcement information. What I'm going to do instead this time is ask the program to suggest some footing dimensions for me. So let me go ahead and click suggest here. And I'm going to confirm by continue. And I'm going to confirm that the reinforcement that was already established will be lost. Okay, so the new reinforcement or the new footing size has been established. Let's go ahead and click the optimize icon again. Now if I were to refer down to the status bar, what I'm going to notice is that my traffic light is green, indicating that this new footing design has passed the code check. Let's go ahead and review some of the additional information we have available to us. Now I'm going to select the Detailing tab in the ribbon toolbar, and what I'm going to notice is that reinforcement for both the longitudinal and transverse dimensions have already been established for this particular foundation design. Now I can modify any of these bars if I want to, either directly in the data panel or by using the longitudinal or transverse generation tools that are also available. In addition to that, I'm going to review my soil pressure information. Here I can see basically a contour plot of the forces and the soil pressures that are on this particular footing, and this is according to the currently selected load case or combination. Now at this point, if you are satisfied with your design, you can go ahead and save this file to the continuous footing detailing module, and you can return to it at a later date. At this point, I'm going to go ahead and close this module, and I'm going to return back to my RAM elements model where I can proceed on with any other design or details that I might have relevant for my particular project.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.